Hello, welcome to yet another episode where we shall be focusing on the basics of the geometric sequences. All right, so in this case, what we're going to be looking at is basically the definition. So we know that a geometric sequence is a sequence of numbers in which each new term, except the first term, is calculated by multiplying the previous term by a constant value. So this constant value is what we know as the common ratio. So if we get your T2 divided by T1, we get the ratio. The T3 divided by the T2 to give us the ratio. For as long as that number is constant across the terms, then we're going to say that is a geometric sequence or geometric pattern. Unlike the arithmetic, where we shall do just addition and subtraction. In this case, it's just going to be a multiplication or a division. All right, so we know that the general term of a geometric is given as AR to the exponent of n minus 1, whereby the Tn is basically the term itself. And then, so this is the value of the term. Okay, A still represents our first term. Okay, and then R is basically the constant ratio, or we call it the common ratio. Okay, N is the position, and then the 1 is always there. So for you to test whether the sequence is geometric, just do that, the division of the consecutive terms. If you get the same answer, then we can conclude that it's geometric. All right, let's look at some examples. So we have this geometric sequence, okay? So determine the next term. So if I get my T2, which is a negative 2 divided by 4, that's going to give me negative a half. If I get my T3, so this is T2 over T1, then I have T3 over T2, which is 1 over negative 2, which still gives me negative a half. So which means I'm multiplying by negative a half. Multiply by negative a half. Then which means I must multiply by negative a half. So which means my next term will be negative a half. All right, then question number 2. Given the geometric, again, we have 256 plus P plus 64 minus 32 and so on and so forth. So this is a term on its own. This is a term, that is a term, and that is also a term. They want us to get the value of P. So since geometric, then we apply the rule of the ratios. So I'm going to say T2 over T1 must be equivalent to T3 over T2, because I mean T3 is 64, T2 is a P, so I have to combine that. So I'll have P over 256 is equal to 64 over P. Then what do I do next? I have to do the cross multiplication. Okay, so P and P, I'll have my P squared. And then 256 multiplied by 64. That seems big. So I have 16384. Okay, that's my value of P. Then I have to find the square root. Okay, square root that and then square root that. So what I'm going to have there, so chances are high I'm going to have two answers, which is like the positive as well as the negative. So the answer I'm getting, I'm having plus minus 128. So which means P is a plus minus 128. But now looking at the pattern or looking at the series, what do you think is the most suitable? Because they said they want the value, not values. Okay, let's see. So if I get negative 32, okay, and then I divide it by 64, that is going to give me negative a half. So which means my constant ratio is negative a half. So since there's no negative in between, the correct value is going to be negative 128. All right. Then last question. I'm telling us that a geometric sequence consists of 3 terms. Okay. Their sum equals 21. And their product is 64. can we determine the possible values of the first three terms as well as the constant ratio? Okay, let's see. So if my first term of a geometric is A, my second term is going to be AR because I'm multiplying by R. And then my third term is going to be AR squared. So scenario number one, their sum is 21, which means if I add all the three, I must get what? A 21. Okay, this is equation one. Then their product, which means A times AR, I'll use dots for multiplication, then AR squared must give me a 64. Can simplify that further. So I'll have A cubed, R cubed is equal to 64. Then what do I have left? If this is my equation 2, I can choose to find the cube root because it's the same as AR everything cubed is equal to 64. So if I find the cube root on either sides, which means AR is equal to 4. Okay, it's up to you. You can make A the subject, or you can make R the subject, whichever option you want. So in this case, I'm going to make A the subject, okay? So it's going to be 4 over R. I'll call this my equation stand and substitute this equation into equation 1. So where there is A, I'll have a 4 over R plus, this is just going to be a 4. And then plus, it's going to be 4R is equal to 21. A is 4 over R. Then that's going to be 4 over R multiplied by R. The R's will cancel and then that. So let's multiply through by R. So it's going to be 4 plus 4R plus 4R squared is equal to 21R. Let's get the standard equation of a quadratic. So it's going to be 4R squared. What is 4 minus 21? That's going to be negative 17R plus a 4 is equal to 0. All right, so we can use the quadratic formula of just vectors. Let me try the vectors and see if I'm going to get somewhere. For me to get this 4, if I have a 1 and a 4, can have both of them to be positive. Can have 4R and R. Is that going to make sense? Because if I have 4R and R, that's 4R squared. This and that is negative 16 minus, that's negative 17 positive. Okay, I think that's perfect. Okay, then equate that to 0 and then we solve this. So the first bracket shall have 4R minus 1 is equal to 0 or R minus 4 is 0. So from the first scenario, our R is going to be a quarter, or the R is going to be 4. Then let's get these values, substitute them to determine the values of A. So we said if R is 1 over 4, then our A is going to be 4 divided by 1 over 4, which gives us a 16. And then if R is 4, which means A is 1. So in this case, we don't have to test to see which one satisfies what, since we don't know the values. So chances are high we can have a scenario where the A is 16 and then the R is 1 over 4. And then chances are still also high that the A is 1, the R is 4, and they'll still give us the same conditions of 21 and then 64. Let's go back to the question, determine the possible values of the first term and the constant ratio. So we found all of that. So guys, that is that. Let's meet again when we're looking at the consolidation, where we shall be looking at all the series sequences and series sums. Okay, look at the possible questions and what exactly is expected. All right, bye-bye.